Hi, I'm Byron Becker, and in this video I'd like to showcase the DataPipe, a browser-based data flow programming environment for connecting Internet of Things devices and external applications, which utilizes machine learning to create reactive and interactive distributed projects. Now, what does the DataPipe do, you might ask? And how does it do this? The DataPipe provides the user with an easy-to-use data flow programming environment for creating distributed projects. It also provides high-level abstractions that enable the user to incorporate networking and machine learning into their projects. Before digging more into the details of the DataPipe, I'd like to now show you a sample project controlling a Spotify playlist with gestures from a wand, and this was built using the DataPipe as the central tool for sending data. The wand has a microbit connected to it and is streaming acceleration values from that microbit. I'm now going to control a Spotify playlist with this magic wand. Okay, so what just happened there, you might be asking? The image you're looking at is an example pre-constructed DataPipe project graph, which in its entirety is taking data from the microbit and sending a transformed version of it to a Spotify playlist application. Looking closer, this example project is taking acceleration data from the microbit and sending it to the light green microbit element via Bluetooth. It's also then routing the selected parameters from this light green microbit element to a blue series classification element, which allows the user to train a time series classification algorithm. In this case, the trained algorithm is receiving that acceleration data from the microbit and essentially classifying segments of that data over time as gestures. The classified results are being sent to a dark green remote sender element that is connected to an external Spotify playlist application, and the remote sender element is sending the classified gesture results to this application, completing the data pipeline or data pipe between the microbit and the Spotify playlist application. In order to create a functional DataPipe project, the user needs to complete 4 straightforward steps. First, they need to construct a project graph specific to the project they're trying to build. Then they need to connect all the external devices applications to their DataPipe project. Following this, they need to configure all of the graph elements, including training models and selecting parameters of each of the elements. Then, after they've configured their project, they can finally run it. In order to build a project, one needs to understand a bit more about the project graph and how to properly utilize it. The project graph is the canvas that users can drag element nodes onto and construct a program. Every DataPipe element has a type defining how that element interacts with data. The following element types below define the possible operations on data in any project graph. These include generators, which take input data from an external source, modifiers, those like machine learning algorithms that take data and transform it in some way and output the result, consumers that take in data and output it to an external source, and pair nodes and project nodes, which combine and split data streams. So the data pipe allows me to connect to different devices and applications. For example, a microbit, which is taped to the end of the stick right here, and a leap motion, which you can see right here. And this reads data from my hand. I've built a little leap motion app in the right of our screen that can stream this data coming from my right and my left hands. So, for example, let's say I want to take data from this leap motion and do something with it. I can use a remote receiver, and there's this concept of a peer ID, which allows peers to communicate and send data to each other, and this is using peer.js. And so our Leap Motion app has a peer ID that we're going to subscribe to, so that when I'm now sending data from my left hand, that data is being received in the data pipe. Another type of data that we can receive, like I mentioned, is from the microbit. So the microbit has a special data pipe element called a microbit receiver. And when we drag this on, this allows us to connect to the microbit via Bluetooth, as there's not currently a universal Bluetooth element connector app that the DataPipe supports, but that's in future works. So when we now want to connect to this, we can pair with it, and now we are streaming acceleration data from this microbit. We can also select different components of the acceleration. This device is streaming its acceleration values right now as acted upon it, and so we see when we selected it and unselect it, the size or vector of what we've selected is in the bottom right hand corner, and that just serves as a visual indicator to the programmer of what data is being sent out from a DataPipe element. So we can see now we can select three acceleration values, and now let's say we want to send this out to another element, maybe a machine learning element. So we can send this out to a classifier, and this classifier first shows up as red. This is a visual indicator of is the DataPipe element working. So in this example, the DataPipe element is not working, and the reason why is because a modifier requires data flowing into it to work. However, when we connect it, it's still red, and this is because it's expecting an input size or vector of data of 3. By the way, this feature is soon going to be replaced with a type system, but for now, this is the way of visually indicating what data is flowing into and out of a node. So this classifier, when we change the input size to 3, can now receive data. Now that we know a bit more about how the DataPipe works, let's revisit the example of using a magic wand to control a Spotify playlist. Except this time, we'll construct it from scratch, viewing what's happening both externally as well as inside the DataPipe application. What we can see here is the Spotify playlist that I'm going to control, and we're going to use the DataPipe in order to control this Spotify playlist. So we're going to drag out as a microbit receiver. We have a microbit at the end of our magic wand. We're going to connect to this microbit. You can see here once we've connected, we're streaming acceleration values from it. And we're going to send some of these selected acceleration values to a series classification algorithm to classify those gestures. I'm going to train a couple gestures here. It's me doing nothing. It's a clockwise circle. This is a counterclockwise circle. And this is just an up and down gesture. And now you can see the outputs of those gestures. And then we can route this to a remote sender where we can broadcast the result of our algorithm to our Spotify playlist. And so now, when we start it, our playlist starts. You can also go to the next song. We can stop that and go to the previous song. Go to the previous song. Loops to the go to the previous song. Okay, now we're at the previous song. And we can stop it. And this is just an example of controlling a Spotify playlist with the magic wand.